class. So we are looking at converting from one form to another when we're looking at parabolas. Now, parabolas come in three forms. Remember, we have standard form, we also have vertex form, and we also have factored form. And we're looking at ways to convert from one to the other. So what we looked at yesterday and the day before, I think, was converting from factored form to standard form and from converting from vertex form to standard form. And we did that just by expanding. And by expanding, I mean using the distributive property to get rid of all those brackets and put it into standard form. Now, what if we were just given standard form? Do you think you could immediately identify a parabola's zeros from standard form? Have a think. Well, I know I can identify the zeros from factored form. I can identify the vertex from vertex form, but from standard form, all I can identify is the y-intercept right there. Nothing more. So the answer would be no. So therefore, it's really important that we learn to change standard form to factored form so that parabola's zeros can be identified quickly. And that's what we'll look at today. So going from the previous example from yesterday, we know that when we expanded this, we got it into standard form quite easily. We actually used a FOIL technique. So we took this very first term of x and we multiplied it into the terms in the second bracket, x times x and x times -6. That's the same as splitting it up like this. So this is a different visual for you. So we did x times the terms in the second bracket, and then we did -4 times the terms in the second bracket. This is the same thing, one and the same. And then we got to this line, and then we gathered these two like terms in the middle, and it became standard form. Now, how can we reverse it the other way around? There's several ways to show you, but the way I want to show you today is by the use of something called Algebra Tiles. So I'm going to go to a little app that I have, and I can send you to this as well. And we're going to take a look at this equation, the x squared plus minus 10x plus 24. Now, I also want you to think about factored form. What do we have in factored form? We have it full of fences. We have a binomial multiplying a binomial, two things multiplied together. So I want you to think about something in real life where you would multiply two things together. Let's suppose we have a letter L and we multiply it to a W, then what have we actually calculated there? What does L and W stand for? In math, where have you seen that? And you would be right if you said it was the area of a rectangle, length times width. So really all we have here when we have a factored form is maybe something times something, L and a W, except it looks a little different. It looks like a binomial. So you're probably thinking, what? So let me explain. We'd like to express this in factored form. If I tell you that it can be factored, then it can be expressed as one thing times another, like a length and a width. So you see over here, we have some little symbols here. We have a symbol for an x squared and a negative x squared. We also have symbols for a positive x and a negative x, and we have symbols for integers. So let's first of all grab all the tiles from the left to represent this bunch over here. So we'll have 1x squared. So the next thing I'm going to do is grab hold of -10x, and I can do that with 10 of these negative x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll grab 24 integers. And there we go. So it says it down here, x squared minus 10x plus 24. So now we need to try and arrange these. Now I need to ask you to try and arrange these to make a rectangle. So how do we do that? Well, these things kind of lock together. What the key to this is you have to have the x squared up in the top left corner. So let's place that up in the top left corner now. And then all these integers have to come off of this corner here. They never, ever, ever touch the edges of the x squared. So let's just start putting them there in the corners here. Now you can grab hold of a couple at a time. if you like, and they just kind of click together like so. Now we could go ahead and put all 24 in a row like this. Now the key with this is that these little integers here have to make a rectangle in themselves, a rectangle or a square. So you could have a rectangle that is length 1 by length 24. That gives you 24. Or there's other ways to do it, but let's leave it like that for now. Now let's take a look at these. We need to make this whole thing a rectangle. So do we have enough of these to be able to fill in up there and keep going and put another one on its side there? Then the answer is no. So maybe we have to configure these 24 integers in a different way. So another way to do it could be maybe a row of 12 and then another row of 12. So let's grab hold of 12 of them and put them under there like that. Okay, so I've conformed by having a rectangle shape with my integers, but I still don't have enough of these negative x's to fill in the missing gaps that are here, right? So this yellow piece here is 2 by 12. 2 times 12 is 24. How else can we get 24? Do you know what? I'm going to start thinking in rainbow factors. So let's think of the number 24. So we can get 24 with 1 times 24. Yes, but we've tried that and it didn't work. What else could we have? 2 and 12. We've tried that and it didn't work. What else could go into it? Well, does 3 go into 24? I think it does. I think it's 3 and 8. And what else could it be? 4 and 6. And I think that's it. All right. So we already know it's not 1 and 24, right? We already know it's not 2 and 12. So let's keep going and let's create instead with this, let's create it 3 by 8. So I think I need to grab hold of these here. I'll put those there and I'll put these over here. There we go. So I've got a 3 by 8 rectangle. I'm happy. Now I've got too many x's on there. So let's get rid of the ones that are hanging over and we should turn them on their side. And let's see what we have now. We can fill in, oh, well, look, hey, is it going to work? Oh no, we have a gap. So this whole thing still represents x squared minus 10x plus 24, but we can't use this to factor it yet because we haven't got a pure rectangle. So this 3 and 8 doesn't work. So let's do 4 by 6. So we have 1, 2, 3 rows. Let's make it 4 rows. So I'm just going to grab hold of some like this. And it has to be 4 by 6 for it to work as a rectangle. There. Okay, now I have 2 overhanging ones over here. So let's grab hold of those and turn them around and put them up here. And yay, look. Whoa, we did it. So take a look at this final answer here. So you're thinking, well, what the heck does this have to do with factoring? I'll tell you what, this is where the magic happens. Are you ready? Here we go. Let's grab a pen. We have x squared, we have negative 10x's, and we have positive 24, which is what we wanted in our equation. But how do we get there with a rectangle? What is the length of this rectangle? Well, if this is x squared, then this must be x, a length of x. So let's write x up here. And a negative x is, the area at negative x is found by x times negative 1. So this length here from here to here is negative 1. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. There we go. Now let's go down the side. What's the side length, the height of this rectangle, or the width of it? This length down here is x for sure. And then we have negative 1, 2, 3, 4, minus 4. And so therefore, we can say the length of this rectangle is, so the area of this rectangle, I guess, is length times width, which is the length of x minus 6 and the width of x minus 4. Oh, how cool is that? if we were in class, I'd give you some actual tiles to play around with. But we've got back to what we had originally. Do you recall? Now, there is a way you can do it without having to fiddle around with tiles, but it's kind of neat to see it. So let's take a look at the two numbers that we actually ended up with, which was this 4 and this 6, right? Now, 4 times 6 gave us 24. Now, you recall that the 4 and the 6 actually were -4 and -6. So we can put a little negative in there. Does that make a difference? Well, for sure. -4 times -6 is +24 still. But the key is that when you add these together, -4 plus -6, you get -10. Look at that right there. So maybe you could do this with rainbow factors and not have to use algebra tiles. But for now, I'd like you to try using algebra tiles because it's honestly really, really cool. We'll do another example. Let's go take a look. Okay, so coming back to this page, how do we start with this and factor it for this? We look for two numbers that multiply to +24. So they multiply to +24 and yet they add to -10. So that's when you'd look at your rainbow factors of 24. You could list them here, 1 and 24, 2 and 12, 3 and 8, 4 and 6. And you're looking for two numbers that would also add to -10 and multiply to a positive. You know that if two numbers multiply together and give you a positive, then those two numbers are either both positive or both negative. But at the same time, if they have to add to be negative, then we know that all these have to be negative. All right, so what do I mean? -1 times -24 is +24. But when we add those together, we get -25, so that's no good. When we add -2 and -12 together, we get -14, so that's no good. -3 and -8, we get -11, that's no good. -4 and -6, we get -10. And so this is the one we use. And what do we do then? We set up our brackets. That's the first step. You put an x in the beginning of each because that gives us our x squared term, right? And you throw these two numbers, -4 and -6, in the brackets. It doesn't matter which way round. -4 times -6 will give us this last term of 24, and -4 times x, -6 times x, when we add them together, gives -10, and that's the magic. All right, so we're going to do one more example. I'm going to take example, which one do you want me to do? Let's go with example A, and we'll take a look at it both ways. X squared plus 5x plus 6. Let's go back to our app. X squared plus 5x plus 6. So let's start with our x squared plus 5x, 1, 2, 3, 4, 5, and then plus 6. We have to make this into a rectangle, remembering that the big x squared has to butt up on its corner to all these integers. So we can just grab hold of these all at one go and go like this. All right, clearly I need to make this a whole rectangle and I don't have enough x's. So 1 times 6 to give me 6 is not going to do it. I need to make this, oh, that's 7. Doesn't help, does it? There we go. So clearly I'm missing a couple. So 1 times 6 isn't going to do it. The only other way to get 6 from multiplying two numbers is 2 times 3. So let's do 2 times 3. 2 times 3 gives me 6 as an area. And these two are hanging over. So we'll get rid of those and rotate them. And then we'll grab hold of each of them and place them up in here. Oh, there we go. That's nice and easy. So what we started out with was x squared plus 5x plus 6. Okay, that's what we have. X squared plus 5x plus 6. And let's count the length along here. Remember, the length of these tiles is x. The length of this tile here is x. And then we have positive 1, 2, 3. So plus 3. And then down the side, we have x plus 2. Down the side, 1, 2. So therefore, we can say that our factored form is x plus 2, x plus 3. Going back to our note, how would we do that using rainbow factors? We're looking for two numbers that multiply to this. So they multiply to 6 and add to this middle coefficient here, add to 5. So you always start out with a multiply side, two numbers that multiply to 6, 1 and 6, and 2 and 3. That's just from the rainbow factors. And we know that they multiply to a positive number and they have to add to a positive number. So all these numbers have to be positive. And then you just check them. You just say, well, okay, what are these added together? 7, so that doesn't work. And 2 plus 3 is 5. So these are the two numbers that you need to focus on, and you drop those into the brackets. Set up binomial brackets, start them out with x, and then just plop these values in there, and that's it. So I want you to give them a go, see how you go. There are lots of resources online that will help you with factoring as well. Some of them I like, some of them I don't. So if you need advice as to where to go, you can. There's also the textbook, which is on the OneNote button. You can look at the textbook resource there. That might help you. And you can go try out the tiles. The tiles are at a website called brainingcamp.com. And click on algebra tiles. Okay, have fun. Take care. Bye-bye.